Excellent.
Hi everyone, thanks for joining us this evening for our Smart in the City meetup. This evening's obviously all about autonomous vehicles, and we've got three amazing speakers joining us this evening. So we have Leo from Jaguar Land Rover, Tristan from Zenzic, and Abdullah from NI. For those of you who don't know me, I'm Hannah Stevens, the engineering manager at Oakmont. Oakmont Consulting is a technology-focused recruitment firm, and we specialise in engineering, software development, and cybersecurity. So if any of you are looking for a new role or looking to grow your own team, then please do get in touch. So I'm also the founder of Smart in the City Meetup, which is obviously why we're all here tonight. So with this in mind, I would like to introduce our first guest speaker, which is Tristan from Zenzic. Tristan, I'm going to send this over to you now.
Fantastic.
There we go.
Let me just share my screen. Second. Okay. Awesome. So yeah, thank you, Hannah. So I'm here from Zenzic, and today I'm here to talk about the UK Connected and Automated Mobility Roadmap to 2030, and particularly around how it affects consensus and collaboration in UK Connected and Automated Mobility. So two really important considerations there. So yeah, I work in the technology team here at Zenzic, so working on a variety of different technical projects, but my focus has been on this roadmap. So I'm aware that there, maybe a few on the call who don't know who Zenzic are and what we do. So just a little bit of background on what we do. So Zenzic was created by government and industry to focus on key areas of capability in the UK connected and automated mobility sector. And we are leading the way by bringing together government, industry, and academia to set the world standard for excellence in this space. Now, core to this is the testing that takes place in what we call CAM Testbed UK. So CAM Testbed UK is a collection of comprehensive and integrated testing sites, all within a 3-hour drive where you can take your concept both virtually and physically from concept to development. And these testing sites range from controlled environments all the way through to a real world environment. So Millbrook here, Hariba Myra and Cabway, these are our controlled environments there. We've got semi-controlled environment at Culham, which is called RACE at the Culham Science Centre. So beginning to introduce a little bit more complexity into the environment there. And then our open environments at Midlands Future Mobility and Smart Mobility Living Lab there. And the data aspect is covered by the Convex project there. So that's a little bit of background, a very quick flyover of what we do. But one of the key things that we do here at Zenzic is this UK Connected and Automated Mobility roadmap. So let's dive in. I'm going to first talk about how the roadmap, consensus, and collaboration, how do they relate? Why this particular title? Well, and I think always in a presentation, good to start with the end in mind. So where are we actually heading? So Zenzic, on our horizon, we've got the at-scale deployment of CAM, the successful, safe at-scale deployment of CAM. And there are lots of benefits to be had here. Notably, safety, a topic that a lot of people in the ecosystem talk about, and rightly so. Human error contributes to, I think it's 86% of collisions on the road, and there are chances here through CAM to reduce that drastically. Also an opportunity to unlock productivity within the vehicle, not having to pay attention to the road in higher levels of maturity of automation. You unlock so much more time in the vehicle to be getting on with other stuff. Also, there's a big opportunity here for improving access to transport, and of course the economic opportunity there as well. So contributing to the unlocking of these benefits is the UK CAM ecosystem, and that is made up of a variety of different sectors. And the way that the roadmap fits in is it enables and unlocks that consensus and collaboration within that ecosystem. But it's a valid question. Why do we need the roadmap? Surely, if we just go back there, isn't that okay? We've got all the pieces. They're contributing the ecosystem is contributing to the benefits. Why do we need the roadmap there? And I guess the first thing to say is that the CAM ecosystem is an incredibly cross-sector and broad ecosystem. And we've got a lot of different traditional sectors here, not just in the automotive or technology side of things, but also aspects like legislation, insurance, and also looking through to how the services are actually going to look when they're deployed as well. And it's worth mentioning that the UK is recognised year on year for their innovation capability. We are incredibly capable, but the point is to realise the benefits of CAM. Because the ecosystem is so cross-sector, collaboration and consensus across these various sectors is absolutely essential to realise that effective scale-up and deployment of these technologies, products and services. And we realise that the impetus to encourage and drive that collaboration doesn't just come out of thin air. We need a central thing, an entity to drive people towards these benefits, towards that common vision. And we at Zenzic, that drove us towards the original release of the roadmap. So this is our definition of what the roadmap is. And the roadmap really drives us towards these benefits that I was talking about earlier. But it cannot be a static document of information. It has to be a tool. It has to have genuine utility through which organizations can see a clear path to scale, find their context within the larger CAM ecosystem, and also reduce risk for strategies, just to name a few things there. So what does the roadmap actually provide? Well, we think it's broadly these four things. So by articulating a clear picture of the coordinated efforts required in this collaborative view, cross-sector relationships can be forged, which are absolutely essential to that scale-up that I was talking about. Having a consensus that is sharpened by experts across academia, industry and government means that organisations can rely on the roadmap to reduce risk for their strategies in connected and automated mobility. The roadmap is also made in such a way that insights can be gathered that are tailored to a specific organisation. There's a lot of complexity and richness in the roadmap, but it can be approached and filtered down and tailored to specific organisations so they can find insights there. And this all amounts in this shared vision, which I've said so far, obviously, is a very important factor in such a cross-sector ecosystem reaching a successful deployment of CAM. So I've talked in terms of kind of definitions, but what do we really get our hands on with the roadmap? What are the various tools? What are the various assets? And here they are. So we've got the interactive roadmap, and I'll dive into that a little bit further through the presentation. But that is where we find all of the information, all the names of activities, the descriptions, the metadata that comes with it, the various tags that we've got across data that you can effectively filter things down. Also information about real world activity that matches up to the various activities in the roadmap. Basically, you go there for everything. It's the kind of richest, most detailed version of the roadmap. We've also got our roadmap report, which launched alongside version 1 in 2019 and has also been updated with our release recently in October. And that breaks down the creation process of the roadmap, as well as diving into some key topics and into what we call golden threads, which I will get onto later. We've got the roadmap overview, which we've had a lot of feedback has been an incredibly beneficial and insightful high level view of the key activities that need to happen between now and 2030 to realise that successful scale up and deployment. And also a selection of insight workshops where we can work either with organisations to see where they fit into the roadmap in a more detailed fashion, or around a particular topic that we want to particularly dissect and go in a bit deeper with. About the creation process. The creation process for the roadmap began all the way back in December 2018, and on this timeline here we've got 2 launches. The first is here in September 2019, which was version 1, and then October 2020, which has just passed there. So we had 6 stakeholder workshops towards our first release of the roadmap. Lots of post-its on A1 roadmaps, then synthesized into various spreadsheets, which eventually amounted into the release of the first roadmap in the different forms that I just mentioned. And then between version 1 and version 2, we identified the key role that gathering real-world data around progress and activity had, and that really underpins the second release, the second update of the roadmap, which I will get onto a little bit further into the presentation. So throughout that creation process, we've had over 200 organizations involved and over 300 individuals. And then these three shapes on the right here are stats about the new release. So we've had 117 CAM creators, those key organizations that are leading the way, that are doing key work towards the delivery of connected and automated mobility, and have put forward information about activity they are undertaking into the roadmap. So you can go to the roadmap and you can find where these 117 organizations are involved in the roadmap and see what they're doing. And there's also information through which you can connect with them. Through the data we've collected for this recent update, we can say that there's over 500 milestones in the roadmap, so over half of them are in action. And we've got over 1,600 new data points as part of this recent release. And this is just a bit of a logo parade to show you the different organizations that we've had involved. And we are immensely encouraged by the appetite across the UK connected and automated mobility ecosystem to get involved and contribute towards this consensus and collaboration, which is just so essential. Let's get onto the roadmap itself. What's the structure? What are we aiming towards within the confines of the roadmap? And as I started at the beginning of the presentation with the end in mind, I'd like to do the same here. So we've got our 2030 vision statement, and we've got two sentences here. So the first sentence here are derived from a series of government principles around safety, equality, accessibility, and environmental considerations for connected and automated mobility. And we work very closely with the Centre for Connected and Autonomous Vehicles in government. And this first sentence is really an explicit articulation of the need to support those priorities and make sure those priorities are core to the development of connected and automated mobility. The second sentence here, kind of in line with one of the benefits I was mentioning earlier, is calling out the explicit need to industrialize and commercialize these technologies, which feed through to that big economic opportunity that we have with connected and automated mobility. So that's the vision. That's what we've got on the horizon. That's where we're heading. What does the roadmap look like in terms of structure? So we realized this was part of our research and when we were creating the roadmap at the start, that there are many roadmaps out there. There are many brilliant roadmaps out there that articulate particular parts of the challenge very well, whether that be in vehicle development or telecommunications, for instance. But as I was saying earlier, because it's such a cross-sector ecosystem, we cannot treat any sector or industry in isolation anymore. So we really need an overarching cross-thematic structure here. And this is what we've arrived at. This is our 4-theme structure, and we think this is a really good way to visualize the various activities which need to take place between now and 2030. And we've come to this structure through collaborative scrutiny with experts across well, the organizations that you saw on that slide earlier, and also many more. So moving through to the roadmap overview, so you've got your 4 themes that were on that previous slide there. And as we move to the right, we go into the streams, the more granular swim lanes, if you like, of the roadmap. And as I said earlier, this is the overview of the key activities which need to take place between now and 2030. And you've got your roadmap stages across the top here, and you've got this interesting phase around about 2025, where broadly we think we're going to be moving from that trials development and enabling phase through to the scale up and realization of those benefits. And I mentioned at the start of the presentation, we work very closely with the test sites of CAM Testbed UK, and test and development is a really core stream in this infrastructure theme here, as well as this first stage, but throughout the roadmap. Now, this is a really good kind of version or asset of the roadmap to get that taste of the high level activities which need to take place. But as I said earlier, this roadmap needs to be a tool we need to have detailed experience with the data, so that we can find where our organization fits in, and we know that there is a lot more detail going on, which is essential to articulate. And that's where we come to the interactive version. Now, this is a screenshot from our interactive version, and at a first glance, I know there's a lot of lines and a lot of different relationships going on, and I'm certainly not expecting you to take all that in or understand that all at once for sure. But the point here with the interactive version is this is where all of the detailed underlying data is. As you'll see, there's a comprehensive and complex web of activity here, and this is just only one of the streams of the roadmap that stretches across all of the different streams there. And the interactive roadmap is where you have access to all of the roadmap data. But you may come to the roadmap and want to find a path through the roadmap that may be independent of the different themes and streams, which brings me on to our concept of golden threads. So we know that there are many ways to slice the pie, as it were, with regards to the roadmap's structure. And we're aware in all of our presentations on the roadmap that there may be people listening who've seen the themes, seen the streams, and think, actually, none of that's really that relevant to me. And this is where we come to golden threads, because we're aware that organizations, individuals want to find paths through the roadmap, independent of those themes and streams, to find that journey across the roadmap's timeframe. So this is just a little bit of a graphic to illustrate how that works there. And golden threads allow those different views of the roadmap to be unlocked, independent of the roadmap's structure. And it shows those dependencies between milestones, themes, and streams. And just to give you maybe a couple of use cases, so that maybe makes a bit more sense. Say you want to get a standards program together, for instance. Well, it may have dependencies on different activities in other streams, and the golden thread approach allows you to understand the dependencies and also what that standards program unlocks across the different areas of the CAM ecosystem. Another example, perhaps an SME might be creating a widget here in the connectivity stream, and it may have dependencies on, let's say, roads and licensing and use. It could have dependencies elsewhere too. The golden thread approach allows you, because the roadmap has relationships at its foundation, to understand those links. What do I depend on? Who do I need to be talking to? And what do I unlock? Who do I actually enable to do more work as the time frame of the roadmap unfolds? So this really provides those paths through the roadmap narrative. But this isn't just at a high level. Again, we want this to be a tool, and we want it to go into the detail that is important for this to have genuine, tangible utility. Now, this is a screenshot from our report, and here we see that the golden thread concept really extends down to that detailed milestone levels. Now, these codes, there's the key on the left here, but these codes represent different milestones in the roadmap. And you can see that the golden thread approach here does extend down to that detail, where you can see activity for activity. What do I depend on, and what do I unlock? And of course, you can go to our report here through our website, zenzic.io, to find out more, and you can download the report through there. Now, I mentioned earlier in the presentation that we've recently had an update. And what have been the key features of that update, and why have we taken that approach? So we had many conversations after version 1, and a lot of the feedback we were getting was, this is a really good articulation of what needs to be done between now and 2030 for this successful at-scale deployment. But who's doing this activity, and what progress are we making? And we took that question and we thought, yeah, this is a really, really key question, and we need to be addressing this with the next release. So we went out and we had an open consultation online with a variety of different organizations earlier this year, and we were seeking data around the progress of real world activity, which you can see here. So we've got our reds, greens and ambers, so our RAG statuses, and our key at the top here. And these colors indicate the different progress statuses of the various activities across the roadmap. And you can open up these activities in the interactive version, and you can see the underlying evidence for their different RAG statuses across a variety of different projects. So that's one part of the release that's just come out. The second part is this activity aspect. So who's doing activity that are contributing to these roadmap milestones, these roadmap activities. And you can see here now, when you open up a milestone or an activity, you get this panel view here. And one of the panels that is new with this update is this contributions panel. So you can see examples here of a real world activity that is taking place, and also expressions of future interest. So those organizations that would like to get involved with an activity in the future as well. And this release really maps onto this golden thread idea brilliantly. So you can see where various organizations fit within the narrative that you see kind of flowing through the roadmap. So you can be sitting in the middle here around 2024, and you've got an application that you'd like to develop. You can get in contact with the organizations that for the prerequisite activities that are currently undertaking work, and you can also see where your activity unlocks other things down the line as well. So we're really bringing that real world, connecting with organizations, encouraging collaboration, really enhancing that experience to bring about that consensus of what real world activity is going on, and making it easier for organizations to connect with each other and find opportunities and partnerships within the roadmap. And if you'd like to find out how you can benefit from the roadmap, please do go to our website, zenzic.io/roadmap. We've also got the CAM Creators Initiative still open. So that I'm afraid it's not on this slide. It's zenzic.io/get-on-the-map. So if you want to be one of those organizations that is putting yourself forward, saying, we are involved in this part of the roadmap, it's zenzic.io/get-on-the-map. All lowercase, yep, no spaces or anything. I don't know why there would be. But yes, that kind of concludes my presentation. Please do go and download the copy of the report online on our website, zenzic.io, access the online interactive roadmap, and please do get in touch via our email address if you've got any questions, info@zenzic.io. Many thanks.
That's great. Thank you so much, Tristan. If anyone has any questions on that, feel free to jot them through. There should be an open Q&A. You should be able to access that really easily. I don't think any have come through at the moment. So we'll move on to our next guest speaker, which will be Leo from Jaguar Land Rover. So Leo, I'm just going to share your screen now. Okay, amazing. Over to you, Leo.
Yeah, can you hear me all right?
Yeah.
Okay, cool. Hi everybody. Thanks for attending, and thanks to Tristan. That talk was very interesting. I'm Leo Rodriguez. I'm currently tech lead of the team in the motion planning and control Jaguar Land Rover, and my talk today is going to be about simulation for autonomous vehicles. I mean, I don't want to give many details on techniques or things that are used, but rather what's being my experience as a developer facing, and what tools, what challenges I've observed for well-performing simulations as a means to validate the autonomous driving development. So, okay, so let me just go. Okay, so let's start. So as I said, I want to discuss what challenges the developers face on a day-to-day basis while trying to develop and validate autonomous driving features with different simulation techniques that are available. I want to just give an overview of what simulation is currently used for in full stack development for autonomous driving, what options are available for this simulation, what's been some of the development experiences, just some sort of reflection on why it's important to choose the right simulation tool set for the appropriate kind of thing. And well, if you have any questions at the end, or yeah, please just write them down. So sorry. Okay, so what is simulation currently used for? So currently, the main the leading companies like Waymo, Cruise, or even JLR or other companies that are developing full stack level 4, level 5 autonomous driving, they are the main use for simulating in general is to be able to reproduce, well, first advanced scenarios in autonomous driving. That's the one of the things that it's very useful. It's hard to see, even though there are companies that are collecting a significant amount of data out there. It's still hard to try to find scenarios in which the decisions that the autonomous system needs to take become are more challenging. So so basically, simulation in general allows us to test these advanced scenarios. We can have multiple traffic conditions. We can basically set the same scenario. This is emerging a scenario, or lane change, or something like that in different conditions, different weather conditions, different traffic conditions. Those things we can test. As I said, we can vary the road conditions and the signage to test behavior, to test perception, and those sort of things. And we can also test different sensor data and sensor arrays. That's the main use. And I here note that the market for just pure automotive driving simulation market is it will reach about $150 million by 2025. And it was already at 135 million in 2019, just purely focused in simulation. And why is that? I mean, many people have heard the mark that in order to prove that the autonomous system is safe, we have to drive about 8 billion miles, and that sounds like a huge amount of thing, but already companies like Waymo have been testing in simulation a significant amount more than those 8 million miles. For example, companies like Cruise, they claim that every day the software is tested in GCP, in Google Cloud Platform, for about 200,000 hours of simulation. So 200,000 hours of driving, and that kind of helps identifying issues that with regular testing and going on the road with prototypes, it's going to be difficult to address. So it is a cost saving. It is aiming to advance the pace for development for autonomous system, because as for OEMs, it's well known that it's prototyping stuff. It's a painful process that they have to go through, but certainly the simulation part and how well has been progressed in the last years, that has helped a lot on the development time. So what options are available? Okay, so I mean, there's obviously, depending on the level of automation that we're looking for, we have to understand what is necessary. For level 1 to 3, possibly hardware in the loop is always mandatory. Software in the loop is necessary in level 2, level 3. we have to make control tests for all these things in a test in proving grounds, but also we have to do field tests. And when it comes about level 4 and level 5, obviously level 4 and level 5, there are sites in the world. Just recently there's been an announcement that Ireland it's building a mobility campus in the west coast of Ireland. So this is primarily for testing autonomous systems. But when it comes to level 5 features, the only solution that we currently have in order to test this is in simulation. There's been obviously attempts in control conditions in field test and test areas where level 5 has been already tested. But driving simulation is absolutely necessary in level 5 because obviously we cannot reach this 8 billion miles driving only in test areas and making field tests. That's I think Waymo it's still in the order of hundreds of thousands of miles that have been driven, and that's far away from the 8 billion miles that needs to be proved. So simulation is a way to be able to speed this process up. So if we think about what kind of simulation we can do in order to develop autonomous systems, level 4, level 5 autonomous systems, we have multiple ways in which we can do this. We have simple feedback loops that we can use, for example, from the trajectory generation part, feedbacking a point in the future. That kind of simulates what perfect control will be, and that is good for testing certain number of things. We then can have simple kinematics that helps primarily to evaluate things like motion planning, decision making, primary decision making, because obviously if we need stochastic decision making, then we definitely need a much more advanced simulator that could provide the uncertainty into the system so that we can be able to test it. We have obviously there's a huge boom in the development of advanced vehicle dynamics, and that's been not new. I mean, in my early engineering days, I was already involved in the development of advanced vehicle dynamics, particularly back then in 2007-8. This was about engine simulation, those sort of things. But right now, the vehicle dynamic simulation for chassis systems, for powertrain, for these kind of things, especially with the recent boom of electric vehicles, this been very important. And there are many tools out there. Particularly, I've had experience with car maker, truck maker, with MATLAB, and then we have like hyper-realistic simulations that they're coming from a lot of developers from the gaming industry have been participating in the development of these simulators, like LGSVL, Carla, and I'm putting Gazebo here because even though Gazebo has a horrible interface, it's still widely used in the robotics community. And myself, I have a strong background in robotics, so I've been quite familiar with the use of Gazebo, but still, that is a tool that some autonomous vehicles company choose as a mean to provide a simulation. And here we have a little table here that shows different tools. I mean, I'm gonna put the links of all of these tools and the different. They're available in the presentation, but and I share the presentation with you. But basically, this is how good, or the markers here represent how good the tool is for certain amount of things. For example, V2X, vehicle dynamics, vehicle integration, sensors, those kind of things. We have there are tools that are available for pretty much everything, and there's tools that are very good for certain things. For traffic, I mean, I've been using Common Road, Sumo, and those tools are amazing for testing really complex traffic situations, but I mean the options and the tools that are available are quite vast, and this is just particularly the tools that I'm aware of that are being currently used in the validation of motion planning. So sorry, I need to go to vision mode. How do I? Okay, so going back to this. Now, as in the development of autonomous drivings, I've tried different approaches, and some of them are more challenging than the others, and some just are very close to be insane. But it is like a thing that we have to face day to day. I've seen things in which we are trying to connect. Well, there's easier ways to connect things. For example, CarMaker, which is a fantastic simulator for vehicle dynamics. It has a very good connectivity with MATLAB. But if we want to choose CarMaker for testing stuff that has been purely developed in C++ without models and this sort of things, it becomes a little bit more challenging because we have to develop all kinds of bridges and translate information from one place to the other. I've seen integration with DSpace tools for software in the loop, hardware in the loop, model in the loop. There's a huge variety of scenarios, and they provide also a very comprehensive set of vehicle dynamics. And I've also had experience with LGSVL integrating with ROS, and LGSVL is a simulator that's been developed with Unity by LG, and this is a very close to reality simulation. It has a very good. This is a picture for the simulator. It has very good sensors, for example, for simulating point cloud. We have a very good, a very realistic traffic simulator that runs underneath, and also the persons that are traveling here. You can see here some scooters, and those sort of things. We can test this, and it's an open source, so there's contribution for the wide community, and just recently there has been significant improvements. So in order to make this tool available, but each company there has their own secret sauce for development. In the simulator, this is an image from the simulator that Cruise uses, and this is an actual simulation. This is not well, obviously it's been rendered, but this simulator is called the Matrix. So this is the simulation, the kind of simulation that Cruise is currently doing, but it's very similar than the stuff that you can see in LGSVL. But it is important to have a clear understanding of what you're trying to prove or validate in order to select the appropriate tool. And one single tool obviously might not be sufficient to cover all your needs as a for a full validation of a feature of autonomous driving. You might need to integrate things together, and you have also to take into consideration the different limitations of the tools that are out there, because there's in my experience, we've spent lots of time trying to connect things together. And I've seen, for example, trying to validate simple motion planning scenarios with Simulink. Running stuff in Simulink involves a lot of development of S functions and things like. There are things that facilitate this already, and we choose to go for the hard way for just wrong tool set selection. But I mean, every developer has probably their particular experience in this, but in general, the consensus is that there are appropriate tools for pretty much everything out there in terms of simulation. Like there's also a problematic amount of high fidelity sensor simulation. It's hard to have it out there, and hard to, if there's, let's say, fantastic simulation for a LiDAR, it's going to be very difficult to port it to simulators that are out there. Even if you have your own platform, putting out a LiDAR model from somewhere else, it's going to be extremely difficult. And this is why, for example, companies like Waymo and Cruise, their simulations teams are massive, and this is because they have to personalize every single thing. So, as I said, we need to choose the right tool for the job. There's many things that we have to take into consideration. It's not only that we just go simulate the stuff, etc. If we want to do this properly, we have to integrate our system in such a way in which we can validate and automatically a high number of miles. And this is done also like in CI pipelines, in continuous integration pipelines. There is there are tools that facilitate already the connection with CI pipelines. For example, AL-Zibdeh has the possibility of running in the cloud, and if you have an NVIDIA processor, you can then you need it to run AL-Zibdeh, but you can then download whatever you have as the simulator, and you can watch the videos of that simulation later on, which is absolutely fantastic. But it's not as simple as I connect. It requires effort, and it requires time to put things together. Open source software stacks like Apollo and Autoware, they have bridges already to open source simulators like Carla and AL-Zibdeh, and there's already efforts for running CI system integration tests automatically. But if, for example, you choose to go to the MATLAB route and you want to incorporate this into a CI pipeline, then this becomes a little bit more tricky, because you have to make it available, and then if for example, you run MATLAB in Windows and you're developing C code, and then you're trying to put together MATLAB and C code in the CI pipeline, MATLAB in Windows, you will face lots of issues. And I've seen engineers really investing a significant amount of time on trying to put things together to facilitate this. But we are getting into a point where things are becoming a little bit more easier to integrate. And there's going to be a point in which basically any change that the development process is going to be subject of hundreds of thousands of lines of hours of simulation automatic in the background, and we won't even hear what's in there. So these are the kind of challenges that myself as in the development of autonomous systems, and not only autonomous systems, but also I've been before involved in the development of unmanned aerial systems, and the challenges are similar. Obviously, with the traffic part, it's a significant component that differs from an AV system. But when you require high fidelity vehicle dynamics, I think that in general there's a lot of effort that's been invested in both areas. And here there is how tools are connected to each other. So it's a cross table. You can read this table as if there's a node, there's no connection to it. But if there is like a check, you have some connection, and there's a reference for a specific article that just shows this. But yeah, so there are still many challenges. Some actors are ahead in terms of the development of tool sets for simulation, but it is important that to be aware that there are a vast amount of tools that could be used for, and I think that developing tools for this particular market, it's quite profitable, especially in the sensor set. There's a huge opportunity in there to develop high fidelity sensor models that will facilitate also the job of autonomous driving developers. So with that, I just want to to conclude my talk. I'm very happy to answer some of the questions. I see already one. So what's the percentage split among using simulation and on the road testing? Well, yeah, as I said, the vast majority of the testing is done in simulation. As I said, to put this in the context, I mentioned that Cruise just drives 200,000 hours per day in simulation, and they're not even reaching the 1,000 hours per day with the entire fleet, with the road, with the vehicles that they have available. So so I think that it's becoming bigger and bigger and bigger, and also with the amount of data that's being collected that it's needed for simulation, for the amount of data that is needed for annotation in order to test AI approaches that are used for develop, then this becomes insanely huge. Annotation is just an entire area for itself, and collecting data, it's also a very profitable part of it. And there's also multiple companies, startups that are working towards this, and also how do we connect this annotated data to simulation. So yeah, is there any other question? Or
Leo, there is a few more questions. I'm not
okay.
sure.
Okay, yeah, now I can see that. Yeah. Okay, the different tools in the supporting features and the supporting features matrix. Yeah. Are there? I'm going to read a few more. So, are any of these simulations environment available online? Yes. So the vast majority of simulations the simulation tools that are mentioned here are open source, and they're available online. I mean, obviously, LGSBL is one of them. Carla, it's also open source. Gazebo is out there. Sumo for traffic simulation, it's also open source. The problem is that with the open source, you won't find high fidelity vehicle dynamics. For vehicle dynamics, you have to spend some money into it, and either if it's MATLAB or CarMaker, licenses are not particularly cheap, but there is room for there's probably attempts for making high fidelity vehicle dynamics, but as I said, it depends on what you're trying to test this the tool you want to use. So there's another one. Is TensorFlow useful for data modeling for objects, road, or for any autonomous driving software? Well, yeah, I mean, AI, it's also a significant component of simulation, but you have to, the controllability of the factors that affect the simulation is very important to really evaluate how safe is the system. So the more like you can have a significant amount of your simulation running like in a black box, and then running with lots of random scenario, like particularly random traffic. They uses a significant amount of AI approaches, with TensorFlow being one of the tools that is being used for that, or like neural networks and sort of things. There's a lot of, for example, of behavior trees that has been used, which and that sort of things. Those are very useful, for example, for traffic simulation. For for vehicle dynamics, there's still more deterministic approaches for that. Does JLR has an autonomous vehicle for road testing at the moment? We do have a few L4 prototypes, and those are usually tested in the. There has been some tests on the road in Gaydon. Right now, due to the whole pandemics, the key part of the development of autonomous driving is currently in simulation. Examples of hardware in the loop, just last one that I will answer. So examples of hardware in the loop, we have many, but some of the tools that are particularly used are DSpace tools. So DSpace, and there's also National Instruments. They also have a comprehensive set of hardware in the loop tools that allows you to test the software being deployed in a target platform sort of things, and then the whole vehicle dynamics is just a series of clusters, and there's even clusters for traffic simulation and those sort of things, and that allows the it's also a very expensive technique for testing integration, but it is the final step prior for commercial deployment, so it is very important. And well, I'll try to answer some of this on the chat, but thanks very much for the questions. They're very interesting ones, and with no further ado, I'll hand over back to Hannah.
Thank you so much, Leo. That was great. Yeah, I think there was a few more questions, guys. I know that you obviously have a lot of questions, but yeah, as Leo says, perhaps he can reply to the last couple on the Q&A. Obviously, just want to introduce our final guest speaker for this evening, Abdullah from NI. So I'm just going to pop you through now. There you go.
Okay, hi everyone. So I'm sharing my screen. Hannah, let me know when you can see it.
Yeah, and I'll put that live now.
Okay, perfect. So just as a start, so NI is National Instruments, and we rebranded around May this year. So May 2020, we rebranded to NI instead of National Instruments. So our vision is to engineer ambitiously, and as you've seen, we work with JLR, as mentioned, in the hardware and the loop testing for autonomous vehicles and a number of other applications. So today I'm going to talk about test and validation challenges for autonomous vehicles. So as a company, our mission is to help researchers and engineers with test systems that help accelerate productivity and innovation and discovery. So our core business is in automated test and automated measurements, and that includes applications such as hardware in the loop for autonomous vehicles. Yeah, so today I'm going to go a bit deeper into that and just discuss the challenges that we're seeing, especially what our customers are facing in autonomous vehicles testing. So just a trend in the industry, what we're seeing is that in the industry, the board is equipment is becoming more and more complex, and you have trends such as 5G, autonomous vehicles, vehicle electrification, IoT, and all of these are driving some challenges that are, when you look at it from a testing point of view, testing is becoming more complex. So testing is becoming more complex. Also, there's an increased pressure on delivering systems to be competitive, and to deliver them on time, and the schedules for the different teams is becoming more and more compressed. So when you think about the product development cycle, testing is actually losing some of the time allocation that it might have previously had, because initially the designers started designing the product, and as the product matures and almost becomes ready to market, and that's like when the testing happens, sometimes there's a pressure to do it as fast as possible, so the test time is actually compressed. So when you look at this from an ADAS or autonomous vehicles point of view, what we've had was so vehicles have had increased autonomy. So for example, you had lane departure warning, maybe assisted braking and so on. But as we move into the future, we have more and more complexity because all of the different sensors that you have in the vehicle are now integrating with each other. They're speaking with each other. And you have, for example, radars and lidars, cameras, you have 5G connectivity as well, potentially you have vehicles to everything as well. And all of this needs to integrate and communicate with each other. So the systems are becoming significantly more complex. Okay, so as I said, so current vehicles have cameras, lidars and radars, but also what we're seeing is that there will be a need for a compute system, complex system to analyze all the data and the algorithms. There's also going to be more and more communication with like communication technology in the vehicle as well. That will be part of this complex system. So when you look at in an autonomous vehicle, so you have the perception part, which is like the sensors, the cameras, and so on. You have then the control and analysis part, which is the computing system, and then you have the ECU that eventually controls controls the actions on the actual vehicle and turns the steering, brakes, and so on. So each of these systems needs to be tested separately and also together. So you have like problems such as sensor fusion when you have all these different sensors integrating with each other. So it's when you think about how to test all of these, it becomes actually a challenging problem to solve. And then, as I said, some of the trends that we're seeing. So the vehicle architecture, the technology in the vehicle is increasing, and that causes the testing to become more complex. There's a lot of regulatory changes at the moment, especially with autonomous vehicles and safety, and that also causes the requirements to change. So, for example, there might be a new regulation that forces manufacturers to change the software or to change how the system is designed. So there's a lot of compliance requirements that eventually need to be tested to validate that the vehicle passes these requirements. Also, there's a lot of focus on software and a lot of complex algorithms. So all of this usually happens in the design phase and then maybe in the validation phase. But when it comes to final testing, it becomes a bit challenging to do all the tests in time. Okay, so as I mentioned, with autonomous vehicles, some of the capabilities that you need to test. So you have the perception part, which is the cameras, GPS, lidars, and so on. And then all of this is analyzed as like detecting the lanes, maybe objects in front of you, classification problems, and so on. And then all of this is then translated into planning and finally control. So you have different systems that require different testing techniques and different systems to test it. Okay, so when you think about the problem of testing autonomous vehicles, at the moment there are currently two different approaches to test. So you have a closed approach, which basically you buy a system from a vendor. It has fixed functionality. It does exactly what maybe the data sheet says, but the user of this equipment relies mainly on the vendor knowing everything, and then it's a locked system. You buy what you get exactly, and there's no room to expand it and so on. And then there's a platform approach, which focuses on giving room for the test engineers and the engineers at the, let's say, an OEM or tier 1 supplier to test, modify and change the test cases, change the test algorithms to adapt to their different test needs. And usually with the platform approach, you have an open system, open ecosystem, and it allows you a lot of modification where you have access also to community that can help you in developing and updating your test. So what we've seen is that with working with test engineers, 72% of test engineers that we surveyed said that they prefer a platform approach. That's mainly because they like to participate and they need to participate in the design of their testers. They are the people who know the most about the challenges that they're facing, And when it comes to autonomous vehicles, each company has their own approach, its own expertise, and that needs to be translated into the test systems that they have. They can't just rely on what a test vendor has, so they need to have their own input. That's why, as I said, 72% of test engineers want to have input on the testers that they use for their equipment. So what we offer at National Instruments is a platform that helps engineers, test engineers and engineers work from the design all the way to production using the same systems. And this also gives them a lot of flexibility, and it's an open platform so they can modify and create their own test cases and so on. So when you think about the platform approach, it all starts from the test requirements. So you have a number of requirements for different components in your test. And then at one stage, you start with the simulation. And as we've seen before, thousands of miles can be driven in simulation versus like a single, like 1,000 mile in testing. So there's a lot of emphasis on testing in the cloud or using simulation. So let's say that you focus on that side, but then as you move to road testing and implementation, you start doing like hardware in the loop and lab tests, which you start integrating the software element with the physical element, and then finally move to road testing or in-vehicle testing. And throughout this whole process, having a single platform means that the same engineers, so the same expertise that is needed to develop the system in the initial stages will be the same expertise needed to develop the system for road testing. So it means less time to train people. You build the capability in-house, so you have more people learn these systems, how to use it, and then they can modify it to be used for different parts of the product development cycle. So there's a lot of advantages, monetary and technical as well. So again, just to reiterate what we do. So when you think of the platform approach, it's not just having the different elements, but also the software that communicates and connects all the different parts. So you probably you're aware of LabVIEW, but we also have a number of other software tools that help connect all the different elements of testing autonomous vehicles, such as VeriStand, which is used for hardware in the loop testing. And then we have data management solutions, because when you're working with autonomous vehicles, data mining and working with big data becomes also a challenge. So we're addressing that. Now, moving back to autonomous vehicles and the testing architecture. So as I said, there are different elements, and now I'm going to talk about a number of examples and requirements that we've seen our customers face, and also the challenges in testing these. So the first part is for hardware in the loop requirements, and also for in-vehicle logging in the vehicle. So when you think about that, you have a lot of data that is coming to the vehicle, to the ECU. A lot of this data is synchronized, but some of it is not synchronized. So you need a way to process and analyze this data in the test system. And also you need to find ways to interface with a lot of different sensors. So for example, you have CAN, LIN, and automotive Ethernet. You need to interface with cameras, with LiDARs, with radars, V2X, so basically communication systems as well. So when you think about a test system that needs to test all of these, you need the flexibility to have all of these different elements. And also when it comes to hardware in the loop, you need a system that can simulate or connect to, let's say, the ECU on one side and simulate the environment on one side for a hardware in the loop test. Again, this is the same thing, but then looking at it from an in-vehicle recording system. So when you have a vehicle that is doing road test, you need a recording system that can communicate with all the different sensors, but also has the capability to analyze the data. Sorry, not analyze the data, compress the data and save it locally so that you can upload it later to your data, maybe data warehouses, and do some analysis on it. And then we have a couple of examples. So we've done this so we've done this with our customers. So we have deployed a system inside a vehicle that connected to, so this is based on a PXI system, and it connected to a number of protocols inside the vehicle. and was recording the data and analyzing it as it drove around. And then also we have a hardware-in-the-loop system that then would simulate part of the environment and also communicate with the ECU. And this is for Vallejo, I believe, and we have a case study at the end with Vallejo. And then moving to the second part, which is around automotive radar sensor production testing. So I'm going to talk here about production testing because it's a bit different than validation. But the idea that we have is that the system that we help R&D engineers to use for validating the initial design can then be deployed for production test. So it is actually it saves a lot of time, and you can use the same experience to test the different elements. It's all based again on the PXI system. And also we have simulation testing. So as we've seen previously, so you need to test a number of high fidelity sensors, a number of protocols and algorithms. So a lot of these scenarios need to be replicated, and you need to drive basically thousands of miles and try a huge number of scenarios which would be impossible to try and test in real life. And for these, we have a partnership with Monodrive, and we also have our own software which expands the capability of Monodrive for it expands the capability to allow you to do hardware-in-the-loop testing and like apply control systems, control algorithms as well. And finally, when you think of an autonomous vehicles, there's a lot of computing and processing happening. So also you need to test the elements that are responsible for doing most of the analysis on the vehicle. So then you think of the chips and the ICs that are inside the vehicle, and for these you need to test the performance, you need to test the power and thermal performance as well. You need to test the connectivity, the electronic part, functional testing for the different communication protocols for automotive networks and network interfaces, but also you need to check and test the sensor interfaces. So this is also a challenging problem because for this you have a lot of networking, you have a lot of power element and communication element, but also there's a lot of changes and a lot of upgrades and modifications that are happening. So for this, we also have a solution which is which is a very flexible test solution. So it is also based on our PXI test platform. So it allows you to add or remove elements as needed and expand your test cases, but also it is open, so you can build your own cases and modify the tests as needed. And here we have the whole, let's say, process from simulation all the way to production. And for each one of these stages, for example, in simulation, I've mentioned the software, and then for in-vehicle recording, hill simulation, and computing hardware validation, we have different solutions, and we can partner with you on helping you with the testing challenges that you're seeing. So finally, we have here a case study from Vallejo. So they used all the different modules that I've mentioned, and they perform in-vehicle logging and playback, closed loop, hardware-in-the-loop, and camera testing. Also, they have developed in-house experience and expertise to develop their own test systems, and this gave them, in return, a great deal of flexibility and power to control their own development schedule. So that's it for my presentation. So how do I see if there's any questions?
Yeah, I think there's one question that I can see. Is vehicle-to-vehicle communication and resonant behaviour part of your testing platform, as there would be more AVs on the road?
Yeah, so we have, so the same platform that we use for this can be used for testing, let's say, communication systems, for example, in 5G or LTE even, before that LTE, but also we're working with a number of vendors and companies on V2X testing. So that will involve using the same platform for potentially expanding it to connect with different different technologies as well. Okay, is there a second question? Yeah, no, that's it.
Does anyone else have any more questions they would like to quickly ask? We'll just give you a moment.
Okay, I guess that's it then. Well, thank you, everyone.
Yeah. Okay, brilliant. So thank you so much, Abdullah, and thank you so much everyone for attending. Obviously a big round of applause for Leo, Tristan and Abdullah. That was amazing. We hope everyone enjoyed the event too. Any comments or feedback you guys wish to share after the event, then please do share with myself. It would be hugely appreciated. So this is our last event before Christmas. Want to wish everyone Merry Christmas, and we hope to see you all in the new year as well. Oh sorry, I didn't realise my camera wasn't on. There we go. Yeah, so thanks again, you three. That was amazing. Thanks for joining us at Smart in the City. Wish everyone a lovely evening, and everyone take care.
Thank you, Hannah.
Bye bye.
Thanks everyone for joining.
Bye, guys.
Bye.
Bye.